Hello everyone, very good evening one and all. Welcome to Gate Wallah and warm welcome to the session. Everybody join the session quickly and mark your presence. Whoever have joined, kindly confirm, am I visible and audible to everybody clearly or not? Am I visible and audible, guys? Please confirm. We are in the lecture number 6 of this arrays data structure. In the last classes, we were discussing about arrays. We were trying to explore about arrays in different dimensions. We have discussed about how we can insert and delete into an array and what is a lower triangular matrix, upper triangular matrix, and then we have also discussed about three-dimensional array, and then we discussed array as a pointer, then stack using array, and today we will be discussing about this simple queue using array. So before I start, everybody please confirm my visibility and audibility. Am I clearly visible and audible for everyone? Meenakshi and everybody else? How are you all doing, dear friends? Hi Raj Sarkar, good evening. Great. So in the last lecture we have discussed about stack implementation using an array. Stack, which is a linear data structure that works on last in first out principle, right? And in stack, insertion operation we call as push operation, removal or deletion operation is said to be pop operation, and access operation is said to be peek operation. So we tried understanding using an array how we can implement these three operations, and while we push, what case we have to handle, overflow case or stack is full or not. We have to check. We can only push when stack has an empty space, right? And pop operation, before we perform this pop operation, we have to check whether stack has some elements to delete or not. So if the stack is empty, we call it as underflow, we will not be able to pop, and even we will not be able to peek. So while pop and peek, we have to check the stack is not empty, and while push operation we have to check the stack is not full. And how we implement that we have discussed. Hope everyone are clear with the array implementation, and the time complexities for all these operations would be constant time complexity. The time complexity would be what? Constant time complexity, right? So in today's class we will discuss what is a queue, And what are different types of queues? In that we will pick simple queue, and we will try to perform insertion operation on simple queue, deletion operation on simple queue. Basically, we will try to understand these two operations today. Okay? So, while late, let us get into the session. Firstly, what is a queue? We have discussed in the last class that data structures are classified into linear, non-linear category. Under linear, we got array, linked list, stack and queue. So, if I want to define queue, how I can define it? It is a linear data structure like array, like stack, like linked list. It is one of the linear data structures, and in this linear data structure, insertion and removal happen from different ends. Insertion and removal of elements will take place from different ends. Unlike stack, we insert and delete from different ends. So, from one end you are inserting, from other end you are deleting. Sir, will this be the case? Always means, again here there is a small clause. If we need to understand that clause, first we have to understand types of queues. What are different types of queues means? We can say there are how many types of queues? Raj Sarkar, Meenakshi, Nishu and all. Will you please tell me how many types of queues first? Tell me the count. How many types? Raj Sarkar, 3 types. Very good. Meenakshi, Nishu and all. We can say there are 4 types of queues. How many types of queues? 4 types of queues. What are they? One is simple queue. Other is circular queue. Other is double-ended queue. Double-ended queue and priority queue. In short, simple queue we can say as queue. Double-ended queue we write as dequue. How do you pronounce it? Maybe most of you guys pronounce it as dequue, right? Most of us pronounce it as dequue, but you should call it as dec. Its pronunciation is dec, not dequue. Okay, the actual pronunciation must be deck. Okay, now as I said, there is a clause for this particular point. There are like conditions apply. In simple queue, if this is the simple queue, insertion happen from one end and deletion happen from another end. Like if we are doing insertion from this end, deletion happen from this end. In the circular queue also, insertion happen from one end and deletion happen from another end. Then how these two differ, we will see. The next class is what? Circular queue. So there we will understand how simple queue differs with circular queue. But in both, insertion will be taken place from an end called rear end. What is the insertion end we call as rear end, and deletion end what we call as front end. So these are like regular queues. Simple queue is a regular queue that you see at the booking counter, reservation counter, or while polling. You might have seen the queue of voters. At the ATM center, you could have experienced the queue. While boarding a bus or train or flight, you could have seen the queue. So that is a simple queue. Circular queue, we can say one popular application of circular queue is in the process scheduling, in the CPU scheduling. There is an algorithm called round robin algorithm, if you remember. So basically round robin algorithm works on this circular, works using circular queue. Okay, then what is this deck? Deck is little different. In deck, insertion and removal can take place from both the ends. We will be able to insert from rear end and delete from rear end. Similarly, insert from front end, delete from front end. So this will be little changing with respect to deck. But of course, there again some constraints are there. Input restricted, output restricted. So when the situation comes, when we discuss about deck, we would be understanding the subtypes of it. And what about this priority queue? Here in the priority queue also, we insert and delete from different ends, but in simple queue, circular queue, what we insert first, that you remove first. So simple queue and circular queue operates purely on first in first out manner. Purely on first in first out manner. Whereas deck, double-ended queue, we may use either in first first out or last in first out. So deck advantage is that deck can be used as stack, used as a simple queue or circular. So deck can be used as both stack and queue. So it may work in either FIFO manner or LIFO manner. But when you see priority queue, it purely works based on not arrival time, based on priority of elements. Based on priority of elements, this works. Again the next upcoming next second class is what? Priority queue. So there we will try to understand a little more about that priority queue nature. So the point I would like to convey is, when I say queue, in general we dictate that in queue insertion happen from one end and deletion happen from another end, but there you have to say terms and conditions apply. That will be applicable for simple and circular queue strictly, but with respect to other, we may need to compromise in the definition. We may need to compromise in the definition. Raj Sarkar, our current class is not about deck. Our current class is about simple queue. Okay. Later we discuss about circular queue, then priority queue. In the same way, when we get deck class, there you will be able to understand about it more detailed. Okay. Just here I would like to convey this point. Insertion and removal from different ends is what? Again, conditional, not for all types. Now let me pick up this simple queue, guys. Let me pick up this simple queue. So what is a simple queue? When I say just queue, not specifically mentioning any type, queue means you can understand it is a simple queue. So in simple queue, insertion happen from rear end and deletion happens from front end. Okay. Like stack use the term push for insertion, pop for deletion. Do we have any specific terms for this insertion and removal with queues? Yes, we have. What are they? Insertion operation is said to be enqueue operation. Insertion operation we call as what? Enqueue operation. And deletion operation we call as dequeue operation. So this you have to pronounce as dequeue. So when I say dequeue, I am referring to deletion operation. Students will confuse between this and dequeue, as both are habituated to call as dequeue, but that's why I am telling this should not be pronounced as dequeue, guys, and it is dequue. So it is deck. Deck means type of queue and dequeue means type of operation. Okay. So now before we go for the implementation, what are different possibilities to implement any queue? Need not to be simple queue, any queue. Queue can be implemented in three ways. Queue can be implemented using either an array or linked list or stack. Usually we say two stacks are used to implement queue, but actually there is a method using one stack also we can actually implement the queue nature, that is a recursive stack, but its time complexity will be exponential, 2 to the power n. That's why that is not recommended. Because of exponential time complexity using a single stack, that is a recursive stack, queue implementation with one stack is not recommended to use. That's why we say queue is implemented using two stacks, so that we will get the time complexity as big O of n. With two stacks, we will get the time complexity as big O of n. There is a procedure where you can implement using one stack also, but its time complexity would be exponential. That's why it is not recommended. Okay, fine. As our topic is not queue implementation using stack, not queue implementation using linked list, we are with arrays. So arrays where you can use all those we are trying to explore one by one. So let us understand how we can implement queue using an array. So when I say queue, what queue I am referring? Simple queue. So queue implementation using an array. Okay, now let us talk about it. Let us say I am taking an array of size 5. Let Q be an array of size 5. We know the default indexing will be from 0. So 0 to 4 will be the indices. What operations we wanted to perform? Two operations, enqueue, dequeue. Enqueue means insertion. So if I want to enqueue as like stack, whatever you implement using an array, as array will be of fixed size, static memory, we cannot assure always there will be empty space in the array to insert the element, right? So we have to always make sure that the queue is not full or queue is not overflow. So when you can enqueue, if queue is not full, then you can insert. Insertion happens from which end? Rear end. Deletion happens from which end? Front end. When queue is empty, initially when queue is empty, nothing in the queue, what will be the front value and rear value? Front and rear will be initialized to -1. Like top is initialized to -1, here front and rear both are initialized to -1. Okay, so front and rear equal to -1. Now I would like to enqueue value 10 to the queue. Value 10 to the queue. So how I can enqueue? Through rear end. But rear is at -1. So what I have to do? Rear I have to increment. Rear I have to increment. So when I increment rare, rare becomes 0. Now in queue of rare, I can insert the value. So queue of rare is equal to 10. So now rare is at index 0, queue of rare is 10. Now how many elements in the queue? One element. So if I wanted to delete, do I have any element now? Yes, I have just inserted an element. But from which end I can delete? From front end I can delete. But where is front? Front value is -1. But front is not supposed to be at index -1 now. Because we have an element, if you want to delete now, 10 should be deleted. So at index of 10, front should be there. So for the first insertion, I have to manually set front to 0. I need not to update front always. Only for the first insertion into queue, simple queue, I have to update front. Now, from the next insertion onwards, enqueue of 20, same operation, increment rare, that means rare becomes 1 and queue of rare is equal to 20. So rare reaches 1, I am putting 20 at index 1. Now what about front? Front should be still at 0 because what inserted first, that will be removed first. In 10 and 20, 10 is inserted first, so that should be deleted first. So front always should be at index of deletion, so front still be at 0 only. Similarly, while enqueue from now onwards, I will be just updating what? Front and rare or only rare? From second insertion onwards, what I would be updating? Tell me. Everybody, what I would be updating? Both front and rare or only rare? Hello? Do I need to update front from second insertion onwards? Not required. Only rare must be updated. Updated means what I have to do? Increment operation I have to do. So every time I go on incrementing, and here rare becomes 2 and queue of rare is equal to 30. Next rare becomes 3, queue of rare is equal to 40. Rare becomes 4, queue of 4 is equal to, queue of rare is equal to 50. Right? So the array size I have taken as 4 and I have inserted 5, array size I have taken as 5 and I have inserted 5 elements. Suppose if I try to insert one more element, into this queue, will I be able to insert? No, it should not allow because queue is full now. So when you can say queue is full? When the rare reaches maximum index. What is the maximum index when the queue size is 5? 4 is the maximum index. Right? As rare is equal to 4, This is indicating queue is full. So now if I say queue size is n, when it is 5, if rare reaches 4, I can say queue is full. If I take the queue size as n, now when rare is equal to n minus 1, that indicates queue is full. That indicates queue is full. Right? So everyone understood how we have to actually perform enqueue operation. This is just the procedure, not the code. Code we will write based on what we have done, we will implement the code. But as of now, everyone understood how we are doing enqueue operation, what we are checking, what we are updating, and how we are inserting, and how we are concluding that from this moment onwards we will not be able to insert anymore. So all these cases, hope you got right. Everyone please respond. Am I clear with the enqueue operation? Okay. Now let there is a queue with the values 10, 20, 30, 40 and 50. Rare is at index 4, front is at index 0. Rare is at index 4, front is at index 0. Now I would like to delete. So when I can delete is what? Dequeue operation. When I can delete, if queue is not empty, then we can delete. Then deletion is possible. Because if nothing in the queue, what we will delete? It is not possible. So we have to make sure the queue is not empty before deletion. That is what we say underflow case. Yes. How we check whether the queue is empty? When the queue is empty, see, queue becomes empty in two cases, in two situations, or at two times. The queue becomes empty in two situations. When initially, when you did not insert anything, delete anything, initially queue will be empty. And if you do enqueue operations and dequeue operations, when you do enqueue operations and dequeue operations, that means you have kept n elements in the queue and deleted n elements, then also queue will be empty, isn't it? Then also queue will be empty. So let's check how we can detect. Initially when nothing in the queue, you did not do anything, what would be front and rear values? -1. So when front is equal to -1, this is what the initial case. This is what the initial case. When front is equal to -1, we can say Q is empty. Okay. Later I am doing enqueue, dequeue operations. Then let's see how we detect whether it is empty or not. Let us check. First, I would like to perform dequeue operation from this queue. From which end I will be able to delete? From front end. Front is at 0. So, delete queue of front. Okay. Assume 10 is deleted. 10 is deleted. Now, what is the next element to be deleted? 20. What is its index? 1. So, front should always stand at the index where you can perform delete operation. So, after you delete, increment front. After you delete, increment front. So, now front becomes 1. Front becomes 1. Okay. Now, again I am deleting. So, delete queue of front. So, front now came to 1. Delete queue of front and then front plus plus. That means front comes to 2. In this way, assume I have deleted 3 more elements. dequeue, dequeue, dequeue. 3 more elements I have deleted. So, what I am doing? After deleting, I am incrementing the front. So, delete and increment. Delete and increment. So, after third deletion, front will be 3. After third deletion, after fourth deletion, front will be 4. So, front deleted and front came here. Deleted and front came here. Now, fifth deletion, delete queue of front. Delete 50 and front plus plus. So, what happened? Front crossed the rear value. So, when front exceeds rear value, then you can say the queue is empty, right? So, when front is equal to or front greater than rear, or there are several ways to implement, guys. In different sources you will find it differently. So, you can say when front is greater than rear, or when front is equal to rear minus rear plus 1, what you can say? Queue is empty. So, if you do enqueue operations and dequeue operations, then also queue becomes empty. Here, by using either of this condition, when front crosses rear as front greater than rear or front is rear plus 1, by using either of these conditions, we can check if the queue became empty or not in the process in the middle, not initially. Initially with front checking we can say. Okay. Now let us go for the implementation part. Everybody, are we clear with this procedure, what we have done? Yes. Once you confirm, we will move on to the implementation part. Clear? Great. Chalo. Now, let us write the complete code. I am including the header file. Okay. Now, there are many ways to implement, as I said. As I want array implementation, let me declare the array as global. So, I am declaring the array q with some 100 as size, let us say, and I am taking n, which is global value, and front equal to -1, rear is equal to -1. So, I am taking all these variables as global so that I can access in any function. Why you have taken? That is my wish. No, you don't want to take in that way. You want to pass it as argument. There you take pointer. That is all your wish. As I said, one program you can write in 100 ways, guys. I am just writing in a simple way, which can be understandable by even a beginner also. So, I am not applying any sophistication here. Right? Now, main function. First, I ask user, what is the size of your queue? Enter the size of queue. Take the input from the user. The user may enter it as 5 or 10 or any number, any integer value. So, I am taking the input. Okay. Now, let me take one choice, like char ch is equal to yes and int choice. Okay. Now, I am asking while ch. See, you may want to do enqueue operation or dequeue operation. Any operation you may want to do at any time, no? Like how we have taken consecutively 5 insertions and then 5 deletions, need not to be the case. I may want to do 2 insertions and then 1 deletion and then 3 insertions and then 2 deletions. In any way, any order I can do, right? So, for that purpose, while ch, this is showing my interest. Do I want to do any operation? While ch, yes. Okay. So, here I am writing while ch is equal to yes. Now, I will ask what you want to perform. Enter 1 for enqueue and 2 for dequeue. 1 for enqueue and 2 for dequeue. I am writing in a simple way. No sophistication I am applying, no techniques I am applying to write the code. Okay, as a beginner I am writing, as per my understanding I am writing. This may be sophisticated in many ways. I am aware of all those, but as a beginner if we write the code, how it will be? Still it works. Still insertion, deletions we will be able to do. Okay. So enter 1 for enqueue and 2 for dequeue. I am taking that input. Scan choice. What you want to do? Right? Now in switch I am taking that case 1. Case 1 is for enqueue. So if you want to enqueue, what you have to do? You have to take the value, no? So you can ask print enter the value to be inserted and scan the value. I have not taken the value. Okay. Now let me call enqueue function. Let me call enqueue function by passing this value as argument and I say break. And I say break. Now in case 2, what I would like to perform in case 2? Deletion. Deletion. So I am printing the deleted value is %d comma dequeue function I am calling. Break. That's it. My switch is over. My switch is over. Now I will take interest. Let's say first I have done one operation. First I have done one operation. What you want to do again? So are you interested again? So let me take the ch before I exit the loop. So this is the end of while. This is end of while. Now end the main. So I have just written the driver code, guys. I have just written the driver code. I am yet to write enqueue function, dequeue function. Let us go ahead and write enqueue function void enqueue of int val. Because I am passing value as argument, so to accept that value as argument, here I am taking val. Okay. Now first what I have to check for insertion, the queue is not overflow, then only I will be able to insert. So let me check if when the queue is not overflow, guys, when the rare value is equal to n minus 1. If rare is equal to n minus 1, that means my queue is full. Print queue is full, or you can say overflow, return the control. Else queue is not full, rare is not equal to n minus 1. Now I will be able to perform insertion. How I can do insertion? By doing rare plus plus. By doing rare plus plus and queue of rare is equal to val. Insertion is done. Now can I go ahead? Can I exit the function? No. For the first insertion, we have to set front to 0. We should not forget. So, now you check if front is equal to -1, that means this is the first insertion, then set front to 0. Return. That's it. My enqueue function is done. My enqueue function is ready. Okay. Now, let us do dequeue function. Int dequeue. Because it returns the value deleted, and that we are printing in the switch, no? Now, before I do dequeue, what I have to check? Underflow condition. So here I have written, if front is equal to -1, there is nothing in the queue, or if front is greater than rear. If front is equal to -1, there is nothing in the queue, or if front is greater than rear, then also I can say there is nothing in the queue. So then you do print what? Queue is empty. Queue is empty, and you can say return -1 or return 0, something like that, or simply return also works. Simply return also works, or else you can write return -1 or just return also works. Okay. If queue is not empty, there is something in the queue. Now I can delete. So else queue is not empty. How I delete? I have to return the value. I have to return the value which is at front, and after I return, what I have to do? Front should be incremented. Front should be incremented, isn't it? So I have to actually handle one case here. What? If front go to rear +1, if front exceed rear, that means queue became empty in the middle. I have done n insertions and n deletions. I have done n insertions and n deletions in the queue. That is also indicating the underflow case. When the queue is empty, where the front and rear must be? Rear, however, I have to set to -1, but front also should come to -1 only, isn't it? So before I do this, I am checking else if front +1 is if front is equal to rear, that means this is the last deletion I am going to do. If front is equal to rear, this is the last deletion I am going to do, right? Okay, I will change something like this, because with the return actually this is the difficulty. Fine. If front is equal to rear, this is the last deletion. So first let me print here only. Print deleted element is, or deleted value is %d comma queue of front. So instead I print in the switch I am deleting here only. Instead I print in the switch, I am printing here only. Then I am incrementing the front. Before I return the control, I am checking if front is greater than rear, that is indicating queue became empty. Now let me set front is equal to -1, rear is equal to -1. Now you return. So with this, if you observe, actually this condition will not be required, because while you delete, you are checking after deletion if front exceeded rear, and you are setting front to -1. So you are not leaving front beyond rear. If at all front goes beyond rear, you are setting front to -1. However, henceforth this condition you can actually remove for checking underflow condition, right? And here in the main, in this switch, I simply call dequeue. I simply do what? Call dequeue, and then break. Did you understand this, guys? Did you understand how I have written enqueue function and dequeue function? Everyone? Please respond. Clear? So now in any order you insert, like insert delete, insert delete, insert delete, or consecutively some enqueue operations, then some dequeue operations, alternative you do, it works. It works. Now again, what is the time complexity, guys? What is the time complexity? For both enqueue and dequeue operations, what is the time complexity? I have not written any iteration or no recursive call. It is simply conditional statements, input output statements, and IO statements or increment statements. So nothing I have written which gets repeated. Right? For one insertion, I simply check insert, or I say I can't insert. Similarly, while deletion, I check whether I will be able to delete or not. If possible, I delete, or else I simply print I cannot delete. So there is nothing that is a repetitive work. So it takes what? Constant time complexity. Constant time complexity. Right? So this is how we will implement queue nature, simple queue nature using array. So today we have discussed what is queue and what are different types of queues, and with respect to simple queue, enqueue and dequeue operations using arrays. How we will be able to do, we have discussed. So that's all for today, guys, and in the next class we will discuss circular queue using an array. Tomorrow, not tomorrow, sorry, on Monday we will discuss about circular queue implementation using array. Okay? Thank you all for joining the session and being very active throughout the session. Keep attending the sessions regularly. Hope whatever we have discussed today, all the concepts are clear for you. Let's meet on Monday sharp 7 p.m. with this topic, circular queue implementation using an array. Thank you so much once again. I wish you all a happy learning and happy coding. Wish you all a happy weekend too. Keep learning, keep growing guys. Take care. Good night everyone. Bye bye. Jai Hind.